surface area of a pyramid and a cone. Very similar to what we've been doing, except when we look at, in this case, a pyramid. Let me move this out of the way. When we look at a pyramid, we notice it only has one base, doesn't it? And so that's what the key difference is in our formulas and in our work. But with a pyramid and with a cone, there's some new vocabulary that goes with this. So just to make sure we understand what these are pointing at, I'm going to highlight some things as we go. Lateral edge. This is a lateral edge. Okay. Lateral face. This would be one of the lateral faces. And how many are there in this picture? 4. Okay, there's one over here. There's one in the background back there. There's one in the background on this side. So those are the lateral faces. Let me get rid of all that mess now. Oh, sorry. Oh, I see, I went the wrong way. There we go. Sorry about all that. So it looks like that. The height of the pyramid, that's the key height of the pyramid, is this distance in here, this dotted line. That's measuring from the vertex to the base. It's got to be perpendicular. So you see the little perpendicular symbol there showing you that's the height of the pyramid. Okay. A base edge. There would be a base edge. There's 4 of them because the base has 4 sides. The base itself is here. A lot easier to determine the base in a pyramid or a cone than it is some of our prisms. Even if the cone or pyramid is laying on its side, you usually identify the base properly. So it's quite a bit easier today than it was yesterday. And then slant height. Slant height is this length here that measures the height of a lateral face. So the slant height measures the height of a lateral face. So we took one lateral side, or lateral face, and we found the distance, a perpendicular line from the top of it to the baseline. Okay? And so I'll pause now, I'll let you finish copying that down. The formulas now, the lateral area formula is a little different. It says 1/2 LP. L is the slant height. And P is the perimeter. Okay, in a pyramid, all the sides are triangles. And so the formula is going to look like the formula for a triangle. This have to be careful here. I didn't identify this, but this is only true for a regular pyramid. Okay, this formula only works for regular pyramids. Okay. Have a rectangular pyramid, this doesn't work. In a rectangular pyramid, you actually have to find the area of each face individually and then add them together to get the lateral area. The surface area formula is true for all pyramids. It's the lateral area plus the base area. Why is it not 2b in this case?
Because it's one base.
Exactly. There's only one base, so it's only plus b. And then a right pyramid and an oblique pyramid, just like with the prisms. The right pyramid, if you drop the altitude down from the vertex to the base, it lands in the center of the base. In an oblique one, it has to be, the plane of the base has to be extended. Okay? Plane of the base has to be extended. For a cone, the concept of oblique and right is the same as all the others, and I've drawn a picture here, right here of looks like a right cone, but we've just tipped it sideways, and sometimes people call that.
Alexis Ripley?
Some people try to draw an oblique cone the way they did there, and I just want to point out that's not an oblique cone. So do the best you can to draw it the way it should look, and if you can't draw it well, remember, just leave me a little note or raise your hand and tell me what you're trying to do so I can give you credit for that. Okay. The formula for lateral area is still 1/2 LP, but because the base is a circle, we're going to elaborate on that formula a little bit, maybe a little more precise for a cone. As soon as everybody gets done copying down the top half, I'll move that up and show you what I mean. So remember, perimeter of a circle is really called the what? Circumference. And what's the formula for circumference? No. That's actually the area, right? Okay. So what's circumference? 2 pi r or pi d, right? So 1/2 times L times 2 pi r. What happens to my 1/2 times 2? Yeah, they cancel each other, right? And they reduce to 1. And so we end up with L pi r, and so we call that, we actually put the pi first and call it pi RL. So lateral area of a cone is pi RL, and so then when we put that into our formula for surface area, we get pi RL, and then Olivia already told us the area of the base is pi r squared, so we get pi RL, plus pi r squared. So those are the two formulas for a cone, lateral area and surface area. Okay. Any questions on how or why I did what I did in blue here? I have a couple examples. I think I have two. Whoops. Yep. 2 examples real quick. Do the best we can. What I tried to draw for you here is a hexagonal pyramid. And then off to the right, I've redrawn just the base, because some of us are struggling how to find the area of the base of a hexagon. I should say the area of a hexagon. Okay? So lateral area, remember the formula? Let me get a pen here. Lateral area is equal to 1/2 LP. Bless you. 1/2 LP. And what's L in this case? 8. What's the perimeter? We don't know yet, do we? I left something off on this. Pause this for a second. So there's the rest of the information we really needed. And so if this side has a length 4, what's my perimeter going to be? 24, because there are 6 of them, right? 6 equal sides, all length of 4. So that's 24. So if we go over here and this side is length 4, what is this going to be? 2. Okay? And so to find the area of a regular hexagon, I'm going to use 1/2 AP, aren't I? Lots of different formulas here. I hope you're starting to understand why I'm telling you it's going to get confusing on these tests, because there's so much to remember from what we've done in the past that's now being used again. What does A stand for? Apothem. And P is the perimeter of the hexagon, right? Which we already found to be 24, correct? So all we need to do is find the apothem, which is this right here. Does anybody remember? We've done quite a few hexagons now. What is this angle going to be? 30 degrees, isn't it? And if you don't remember why, we could draw the rest of these in. How many equal pieces are there? 6. 360 divided by 6 is 60, so that means each one of those is 60, so this little one here is going to be 30. It's going to be half of that 60. So we have a 30, 60, 90. If you don't remember the rule for 30, 60, 90, then you'd have to use trig. Opposite and adjacent is tangent. So tangent of 30 is equal to opposite over adjacent. Am I in the way? Sorry. And then, because the unknown's in the bottom, what do we do with them? Switch places. So A is equal to 2 over tan of 30. And so A is 2 over tan 30. Remember, we don't want to round at this point because we'll run into a rounding error later probably. You can simplify some things if you want, because I see a 2 in the bottom and a 2 in the top. They do cancel. And so in this 24 is really over 1, so that puts it up top. So we really get 24 over tan 30 for the area of the base. Oh, thank you. I said 30, didn't I? I just didn't write it. It should be tan 30, not 24. Okay, good catch, Chandler. Thank you. So, if I add that to this, then the surface area is going to equal half of 8 is 4. 4 times 24 is 96. Plus the base area, which is 24 over tan 30. And if I round that to the nearest tenth, I'll have my surface area. Okay? Anybody do that on their calculator so I can write down a number?
137.8, maybe 137.6.
And I didn't put a unit, so I'll just say unit squared. Okay, 137.6. Now, one last thing I want to mention. They might ask you for slant height. They might ask you for height of a pyramid. When they're asking you those things, what you need to do is realize that you might be looking at a right triangle. Or this right triangle. Shucks, let me, I had too much going on in there. or this right triangle. You might have to use some of the information in Pythagorean theorem with these right triangles to find the missing parts they're asking for. So some of these questions today, tomorrow, whenever you get to working on them, could be asking you just some simple things like that. They don't all expect you to do all of this in them. Okay? There might be little groundwork type questions just to help you understand more about what a pyramid is and what its parts are. Okay, and this last one here, we're not going to do it all. Oh no, we're not going to do it all at all because it's review. What is this angle going to be? In this angle? 45. Okay? I must have thrown this in. There must have been somebody had a question on it. When I was cleaning it up today, I didn't realize it. So we're not going to take time to do this. If you want help with a problem like this, you'll run into it on the homework today, and you can ask, and I'll gladly come around and help you. So, tomorrow's a work day, all day, all period. Okay? So, today and tomorrow's homework added on to what you've already done is 1 through 20 all. Some of them are going to be a little time consuming, so I am very open to Friday being another work day. I'm not saying I'm going to guarantee it, but I'm very open to it. You just work the rest of the class period today, you work all period tomorrow, and if we're not done, then we're going to definitely have time, if not the whole time, on Friday to work some more. All right? Any questions?